So comparing old math to new math, these are just some things that are happening with old math that we're trying to get away from, okay? So it's a bunch of steps to memorize. And let me say this, I will say this too. Old math isn't bad. The way that you learned math when you were in school isn't bad. It's not wrong. The way that you learned how to do math is correct. It's the right way to do it. And it's probably honestly the easiest way to do it. But that doesn't mean that that's how we need to teach it to kids. It's not the easiest way to understand it, and it might not be the easiest way for every single student in the classroom, okay? So just know that when I'm talking about old math, I'm not saying it's terrible, it's bad, and the way you learned it was bad, and you're the worst in the world. I'm just saying that old math, these are some things that we're trying to maybe get away from. So it's a bunch of steps to memorize. You were taught first you do this, then the next thing is you do this, and then you do this. You were only given one way to solve a problem, possibly. They say, well, this is how you add. This is what you do. You add this way, you subtract this way, you multiply this way, you divide this way. And that's just how you do it. And also, they didn't really do a very good job, I think, when I was in school, and what we've kind of noticed is we haven't really always known the best way to, or the reason why we're doing those steps. You might know the way to add. You might know you need to carry the 1 over. You might know that when you're multiplying, you need to carry a 1 or a 2 or something like that, but you might not exactly know why. And so that's what we want to try to teach the kids is why. So this is what the things that we're trying to do with this new way of math. So these are the things that you're going to see me trying to explain while we're doing this. So explaining why we're doing these steps, right? That's the first one, explaining why these steps work. Different methods or ways to solve the problems. Yes, the way that you learned it is correct, but it's not the only way to solve it. Different modalities, right? Modalities are things like visual, auditory, standard algorithm, numbers. These are all just different ways to solve the problem using different methods. You can solve it with pictures. Some people's brains work better with pictures. Some people are just numbers, numbers, numbers. We don't need to get pictures involved. I can just do it with numbers. That works too. Giving the tools to solve problems is the number one thing that I think is really important about the way we teach math, is that kids like to do this thing where you give them a math problem and they sit there and they stare at it for 10 minutes and they think by staring at it, they are going to, the number is eventually going to just pop in their brain. I see it all the time. They'll just sit there and look at a problem and they're like, maybe I can just think of it after 10 minutes. Maybe it'll just come to me. So the reason why this is important is because we're going to give them tools. If you don't know how to do 6 times 3, well, you can draw a picture. This is a tool. You can do 8 different things to try to find out how to solve this problem. Camila's parent, I'm going to try to bring you into that other meeting right now. It should be calling you, and you should be going into the other meeting, possibly. There it goes. It went. Okay. All right, so we're going to start off with something that parents told me that was really important to them is place value charts. And we're going to focus on how to add and subtract with them. You can do anything with place value charts, but Mr. Hernandez just texted me and said now they can't see him. Oh my goodness. Give me a second here. I'm letting him know. Try spotlighting yourself. Okay, we'll see what he says to that. Thanks again for being patient. So we're going to do adding and subtracting within a place value chart. And really, we're just going to kind of talk about a place value chart. So this is a place value chart. It just has the place values in it. It has the ones, tens, hundreds, thousands, and really what that is, what those each individual parts are, is it's different powers of 10, right? So the ones place is going to be 10 to the 0th power because that's just 1. The tens place is going to be 10 to the 1 power because 10 to the 1 power is 10. Hundreds place is going to be 10 to the 2nd power, or 10 squared. And then the thousands is going to be 10 to the 3rd power, and it's going to keep on going, so on and so forth. Onel, Onel's parents, do you guys need Spanish? Espanol?
Yeah.
Okay, I will move you into a new room real quick with Mr. Hernandez where he'll teach it in Spanish. All right. So the way that we use these place value charts here is we just put little place value discs in the middle or inside these parts. So if we wanted to put 3 in here, we would say that is 3 times, really 10 to the 0 is 1. So it'd be 3 times 1, which is 3. If we had, let's say we have 4 in here, it would be 4 times 10 to the 1, which is 10, which is 40, right? So each one of these discs represents 10 instead of 1. So that is the place value chart is just each power of 10. So we have 10 to the second, which is 100, right? So if I have 2 in here, that's going to be 2 groups of 100. Or we could say that's 10 to the second. And then the same thing for the thousands place. And when we get decimals, we have the decimal right here. And then we do something over to the side. It's going to be, obviously, it's tenths, which is going to be 10 to the negative 1 power. So if I have 2 or 3 in here, it's going to be 3 times 10 to the negative 1, which is basically just 10 times 0.1 to the 10th, which would be, or I'm sorry, not 10 times, it'd be 0.3. And so that's just kind of an intro to what place value charts are. I don't explain it that way. This is not how I would explain it to children. This is how I'm explaining it to parents. But just know that each place value, when they go over to the next place value, it's going to be the next power of 10. If I end up having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I can't have 10 in the ones place. That would mean it goes over to the tens place. So I would have to, you'll see this, I'd have to bundle this up, move this over here. And those 10 ones turn into just 1 10. Okay, so we're going to add with a place value chart. We're going to go ahead and we're going to do, we'll just do a, what did I have here? We'll do a 3-digit plus a 2-digit. So I have, and the cool thing about place value charts is they're really quick and easy to make for the kids. Ones, tens, hundreds, and let's say we're going to add 136 plus, let's say, 82. So this is the way that I would teach it in my classes. I would have the standard algorithm, is what we call that, the standard algorithm right there, and then we're going to do a place value chart right here as well. We do it side by side. We're not trying to get rid of the standard algorithm. We're just trying to show them different ways to think of it, more visual ways to do it. So we would start off by we always start with the ones place. We're going to do this top number here first. So we'd have 1, 2, 3, 4, 5, 6 ones. And then we go to the tens place now. We have 1, 2, 3 tens. And then in the hundreds place, we have 100. And then I'm going to go ahead and I'm going to add the next number, the bottom number here. So I have, in the ones place down here, I have 2 ones, 1, 2. And in the tens place here, I have 8, 1, 2, 3, 4, 5, 6, 7, 8. You might already be thinking to yourself, hold on, can't have that much in the tens place. We'll get there. So we start off just by going 1, 2, 3, 4, 5, 6, 7, 8. 6 plus 2 is 8, obviously. And then in the ones place, we have 8 here. So they just count it out. Count out how many discs do we have in the ones place. And then we go to the tens place, and we have 8 plus 3 more, 8, 9, 10, 11. Oh no, I can't do that. So I have to bundle up, just like we did in the last one. I have to bundle up. This is what we teach them. 8, 9, 10. And I keep that 1 there because we have the 10 here moves over to the hundreds because we have 10 groups of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Once we have 100, we got to move over to the next power of 10. And we add 1. So then we had what's left over in the tens place is 110. And once we bundle everything over and move it over here, now we have 200s. And so to model that with the standard algorithm, 8 plus 3 is 11. We have the 1 left over, right? Once we bundle it, we have the 1 left over. But we can't forget that once we have 10 tens, we got to bring it over here to the hundreds place, because that extra 1 can't live in the tens place. It's got to live in the hundreds place. And then we have 2 hundreds left over, and that's how we do that. And so this is kind of, I mean, this is a very fast process of going through this for the we are doing this a lot faster than we would do it in class. But this is just kind of, when you see this on homework, when you see us using place value charts, this is how, this is what this means. This is how we do it. And then we can show subtraction with the place value chart. So now we're moving on to subtraction. The key thing with subtraction is it means take away, right? Some students don't really know that, but it means take away. And so we can show that same thing here with a place value chart. So I believe I did, let's do something easy, 62 minus 35. We have the ones, the tens, the hundreds. Lost my N. There we go. We're actually not going to have any hundreds now that I think about it, because we're just going to do 2-digit times or minus 2-digit. 62 minus 35. There we go. So when we have the standard algorithm right next to the place value chart, which is what I like to do, I always tell the students the number on top, right? Because subtraction, it matters which number comes first. In addition, it really doesn't. 2 plus 5 is the same as 5 plus 2. Doesn't matter which comes first. In subtraction, 2 minus 5 is a big difference from 5 minus 2. It matters which number comes first. So I like to tell the students the number that's on top is the number that we have. I have that much. I don't have 35. I have 62. 35 represents what is getting taken away. I have 62. I'm taking away 35. So we're not going to put 62 and 35 in this place value chart. I don't have 62 and 35. I just have 62. And so we're going to start off by putting that in the place value chart. That's what we're going to do. We're going to show in the ones place, we have 2, 1, 2. And the tens place, we have 6, 1, 2, 3, 4, 5, 6. Now, again, some students will try to put that 35 in there as well. Well, you'll notice if I put 35 in there, what did I just do? I added. I didn't subtract, I added. I put more inside the place value chart. And we don't want to do that. That's the opposite of what we're trying to do. So we start off by showing, I'm going to subtract 5 from 2. Now, I would just cross these out, but obviously you are noticing, as the smart parent that you are, you're noticing I only have 2, I can't take away 5. This is what I want the kids to see too. This is why having this is so important, because I want them to see I don't have enough to take 5 away. The kids don't understand that. It's really hard for them to wrap their mind around the fact that I don't have enough to take 5 away. Because what they'll do is they'll just say 5 minus 2, that's 3. No. You can't switch these around, right? We can't do that. The number that's on top is on top for a reason, and you have to keep it that way. So I want them to notice, man, I don't have enough to take away 5. I can't cross out 5 here. And so that is why we have to go to the next place value. And the way I like to put it is take 1, give 10. Okay? And this is how I show that. Let me try to move this up because I think that's going to get in the way. Move it right here. Take 1, give 10. I go to the next place value, and I'm going to take 1 from it. So I'm taking 1 from the tens place here. I need to have more in the ones place so that I can take 5 away. I don't have enough. So I take 1 from over here, I bring it to the ones place. Now, I just took a 10, right? I didn't just take just a random 1. I just took a 10 and I'm bringing it to the ones place. I can't put a 10 in the ones place. That won't work. So I have to put 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've taken this 110 and I've brought over 10 ones. And so now I say to them, we don't have 2 anymore. We have 2 plus 10 more ones, right? And so the way that looks over here on the standard algorithm, which is what you already know, the way you were taught, we take 1 from the 6, that makes it a 5, which you notice here. We give 10 to the 2, that makes it 12, because we already had 2 in there and we're giving 10 more to it. All this helps the students with number sense. We really want them to know that when you go from one place value to the next, something happens. It's another power of 10. It's another, it's 10 times as much in the next place value, right? So all this really helps them understand that if I take a 10 and bring it over here to the ones place, I'm not just bringing a 1, I'm bringing a 10. So now we have 12, we can take away 5. The way we show that in here is we just cross out 5. 1, 2, 3, 4, 5. And so then we have 5 right here plus 2 more. So we have 7. Boom. And then we go to the tens place. We did have 6. Now we only have 5 because I had to take 1 give 10. So now I have 5 in this tens place, and I'm going to cross out 3. I have 5. I'm taking away 3. 1, 2, 3. Now how many do I have left over? 2. And we can show that here. So the way I do this in my class, and I think the way a lot of teachers do this, is we have the Common Core version right next to the version that no doubt or undoubtedly is much faster. Yes, they're not going to do this the rest of their lives. I don't. You don't. No one does. But hopefully you can see how this helps them really understand the why behind all of this weird stuff going on up here. So next is multiplication. So I've taken you through addition and subtraction, just the way that we model that through the place value chart. Obviously, it's not the only way we model it, but it is a way that parents were telling me that they were interested in, was place value charts. So now multiplication. I was a third grade teacher for the past 3 years. Multiplication is life. It is the biggest thing we talk about in third grade, and there's a lot of ways to model it because they've never seen anything quite like multiplication. Students don't really understand the concept of multiplication. They like to add, and then when we bring in division in third grade as well, their minds are blown. They're like, I have no idea what's going on. So you'll notice a lot of different ways to model multiplication, and that's because we want to really drill it into their head that this is what multiplication is. Look, here's one way to show it. Here's another way to show it. Here's another way to show it. Do you get it? Do you get the groups? Do you understand? That's kind of what we're trying to do here. So I said here, the key to multiplication is to think of the multiplication sign as groups of. This sign means groups of. That is third grade in a nutshell. The multiplication sign means groups of. That's what it means. So when you see 3 times 15, we tell the kids to think of it as 3 groups of 15. That's multiplication right there. There's a way. One of the ways that we can show it is repeated addition. 3 times 15 is just 15 plus 15 plus 15. Now we don't start with 15. We start with numbers like 3 times 2, and we show 3 groups of 2. Things that they can skip count by, right? They can go 2, 4, 6. But here we are with grown adults. I don't need to do the small numbers. I can show you 3 times 15 is 3 groups of 15. You can add that together to be 45. This is important for them because they see something like this and it's alien to them. They have no idea what this sign is. They see it, their brain doesn't know where to go with it. So we show them, look, if you ever see something like this sign, you know that you can just add this number 3 times, 3 groups of 15. Another way that we can model this visually, so this would be like a numbers. This is the way you can model it with numbers if you're a numbers thinker. But a more visual way that we can show it here is a tape diagram. If you have a kid that has been in third grade, you're going to hear about a tape diagram. And if you don't know what it is, it could be pretty annoying, I'm sure. So diagram, I think of it as just like a piece of tape, right? It's just a rectangle. You take a piece of tape off of the roll, it's going to be a rectangle. And we can cut that up in a million different ways. So we say this whole thing is our whole. And we can break it up into 3 groups of 15. So we have one group. We got 15 in here, 15 in here, 15 in here. So this is 3 groups of 15. And I can say that the entire thing is 15 plus 15 plus 15, 45. This is really helpful for kids when they don't actually put the numbers in there. They might even just do, like if we're doing, let's say we're doing 3 times 2. Let's go down to that. And they know, okay, 3 groups. So I got to make 3 groups. Now I have 3 groups in here of 2. So they put 2 dots. And now they can say, okay, well, I have 3 groups of 2. So what is it? 1, 2, 3, 4, 5, 6. Oh, the whole thing, 3 times 2 is going to equal 6. That makes sense. They kind of, so this is an example of a tool, right? If they don't know what 3 times 2 is, instead of sitting there and looking at the screen for 10 minutes, they can actually draw it out, and they can draw 2 dots in each group, and they can count it. This is something that they can literally like figure out right there in, with their pencil and paper in their head. Another way that we can model this is a number bond. Number bonds come up, I think the first time they come up is in kindergarten. I know they're in first grade. They're starting out by showing you addition, right? So they start off by saying, you know, a way to show addition would be if we have 3, we can show that with 2 and 1. Pardon that being so sloppy. 2 and 1 together make 3. Look, that's how they learn it in like kindergarten. Well, we use this because they know this in kindergarten. They know this in first grade. We use this concept, this thing of the number bond that they've seen before. It's a familiar thing to them. It's a familiar model. And we say, look, we can take this thing that you're familiar with and we can show you multiplication with it. If I'm doing 3 groups of 15, I can show 1 group, 2 groups, 3 groups, and each one of them is going to have 15. Again, I would never use 15 with the kids. I would use a smaller number. But you can see how they would go and say, oh, 3 groups of 15, that makes sense. I can just add 15 and 15 and 15, and it's going to be 45. Okay? Just another way to model it. It's just, you're going to see a repeated, we're drilling this into their brains so that they absolutely have no doubt that this sign equals groups of. That is the number one thing here. Okay? Another way, you're going to see arrays. Arrays are so crucial to 3rd grade. There's a lot of things you can do with arrays. And really, it starts off by saying, look, I can do the same stuff I've been doing with the number bond, with the tape diagram, with repeated addition, and I can just draw it with dots. So I did this for you because I didn't want to spend time doing it because it might take a little bit of time with 15, but I drew 3 groups of 15 here. So you see we have rows, right, and columns. And so we can show them that we have 3 groups of 15 because look at how many rows there are. There's 3 rows. What's inside each row? 15. So we have 15 here, and 15 here. It's 45. And arrays are really, really important for teachers because in 3rd grade, another thing that they're taught the first time they ever learn this, you'll see 3rd grade is a really crucial year. Another thing that they're taught is they're taught area. Well, you can see how if they understand the concept of an array, look at how much that would help them with area, right? We know that the formula to find the area of a rectangle is you take the base times the height, or in 3rd grade, you could say the length times the width. Either way, it doesn't matter. Those both equal the area. They'll get you the area. And the reason why we do that is because we're just making an array. So if they understand the concept of I can show 3 groups of 15 by making 3 rows of 15, then when they see an area that looks like this, they can say, oh, so this is 1 square foot by 1 square foot. I know my picture isn't doing it justice. It's not exactly a square foot. It's more like a rectangle foot, but that's just because I am drawing this on a computer and it's not the nicest. But you can see how they would say, oh, this is 1 square foot, 2. They can count all of these to find the answer. But really, it helps them understand that, oh, so I can just take this side, which is 3, see 1 foot, 2 foot, 3 feet, and I can multiply that by this side, which is going to be 15 feet. And instead of counting each individual one, I can just treat it like it's an array and say, oh, that's going to be 3 by 15. 3 times 15 is going to give me the area of every single square foot in here. Right? And we go a lot more in depth in it. This is like a 2-month process of teaching them area, the whole concept of area. But you can see how an array really lends itself in the grand scheme of things to teaching area. And we definitely don't teach area until we teach multiplication to them and how to use an array. So sometimes you're like, why are they doing an array? This is such a dumb way to do multiplication. You don't need to do it like this. You can just do it like this, or you can remember just skip count by threes. And it's like, yeah, you're totally right. Absolutely. But it might lend itself towards a concept further down the line, like area or other things. So those are just some of the different pictures that we can draw to help show them area. And then we're going to get down into the number stuff here. Partial product. Partial product is just another way to give them the number sense of the ones place is different than the tens place, which is different than the hundreds place, which is different than the thousands place, and so on and so forth. So if we're doing, what did I do over here? I did 15. Oh, I did 15 times 3. So if we're doing 15 times 3, right? Instead, I mean, this is probably the way I would do it. If I had to know what 15 times 3 was, and for some reason I couldn't just think of it in my head, I would draw it out like this. But partial product is a little different in the sense that we go 3 times 5 is 15, write the whole thing out. And I say this 15 is actually 3 times 5 ones. And then I go over here to the tens place, and 3 times 10, which is 30. And that represents 3 times the 1 in the tens place. And we want the kids to know this is not a 1. This is a 10. It's in the tens place. This 1 is not just 1. It represents 110, which is 10. And then we have to put it together. I do 5 times 3 and then 1 times 3. And we have to add it together here, which is going to be 45. It really makes a lot more sense when we go into hundreds, because then they can kind of say, okay, it kind of helps them sequester. I don't know if I used the right word there. It kind of helps them block it up a little bit easier, chunk it up a little bit easier, you know? And so it's just another way that they can multiply, right? Like I said at the beginning, we're trying to show them different ways to do things. They don't have to do it one way. They can draw things. They can do it partial product way. There's even a way that I've never taught, and I understand the importance of it. It's called lattice, and it involves a lot of sideways things. I personally, having been a teacher for 5 years, I've never had a curriculum that told me to teach it that way, and I've never taught it that way. Doesn't mean it's a bad way. I've just never taught it that way, and I've never had a curriculum that says that you have to teach it like that. If your parents' teacher, or your parents, if your kid's teacher is having them do that, then I would ask them about that. I wish I could be more of assistance. I just have never done that before as a teacher of 5 years. And then we have the standard algorithm, which is what we all know. It's the fastest method. It's tried and true. You don't have to do a bunch of weird stuff. You can say 5 times 3 is 15. Let's put the 5 here. And let's bring that 1 over here. I'm going to take 3 times 1, which is 3, add an extra 1, which is 4. Boom. It is the most efficient way. But do you see how if they don't understand that 15 times 3 is 5 groups of 3, or it's, I'm sorry, not 5 groups of 3, it's 15 groups of 3 or 3 groups of 15. If they don't understand that process, if they don't understand what this sign means, teaching them the standard algorithm is just teaching them just how to follow steps, which is great if you want to get the right answer, but it's not great for if you want to understand the process and understand why are we doing this. Again, that is the biggest thing, is why are we doing any of this? Why do I bring this 1 right here and put it there? Why is it, what is an array? Things like that, right? So that's multiplication. Well, no, we have one more multiplication. It's called group size total. So I do this a lot with word problems, okay? Group size total. So let's take an example problem here, and I'll show you how I would do this and how you might see a teacher do this here. You get an example problem. Aaron has 3 bags of Skittles. I didn't say has, I just says Aaron 3 bags, so my apologies. There we go. Aaron has 3 bags of Skittles. Each bag says it contains 15 Skittles. How many Skittles does Aaron have? Well, words are really, really hard for any student in general because it combines their 2 least favorite things, reading and math, right? So they see something like this, they might go, oh, 3, 15, 3 plus 15 equals 18. Boom, Mr. Harding, I'm done, problem over, right? They just see a 3, they see a 15, they're just gonna add, they're gonna do whatever without actually reading it and understanding it. And so I always teach group size total because a group, if you're noticing that there's groups involved, it's not just, 1 plus 2. If there's groups involved, it's going to be either multiplication or division. And so this is going to kind of bleed over into division here. But we make a group size total, which is just a rectangle here. And I just label it as group size total. And we tell them, do they give us groups? Do we have groups in this story? Well, it says 3 bags of Skittles. So that's groups of Skittles. Bags are groups. So I know that for my groups, there we go. For my groups, we have 3 of them because it's 3 bags. It's not just, 3 plus 15. We're talking about groups of something. And how many Skittles are in each bag? Let's see. Each bag says it contains 15 Skittles up. So my group size, the size of each group is going to be 15. And do I know my total? Nope, it's asking me to find the total. So this is kind of them reading a problem and, decomposing it, fleshing it out. What is it actually telling me? Because these kids, any kids in general, will just look at that problem and say 3 plus 15 every time. And they won't understand why that's not working. Why is that the wrong answer? So when you can really get them to read it and dig a little deeper, understand, is this groups? Is it telling me to multiply, to divide, to add, subtract? And so then they would know, okay, well, if I have 3 groups and each group has 15 in it, that's going to be like 3 groups of 15. So for me to find my total, I would just take 3 times 15. And so that's how they can kind of check themselves and say, oh, it's a multiplication problem. That's how we can do it. There must be 45 Skittles in there because I know that 3 groups of 15, and they can draw a picture, they can do whatever. I know that that's going to be 45. Okay, and I like to teach students that, what if I give you a problem and I tell you there's 45 Skittles and there's 3 bags, how many are going to be inside that bag? Right, so I give them a total. I tell them that there's the group size, but they need to find out the groups. So that's going to kind of lead us into division, because I like to think of division as, and the way that we teach it is backwards multiplication, right? Division is such a weird concept. I'm a middle school teacher now, and my 8th graders are still not understanding division. They don't know what it is. And this is the last part here. So we're on the homeward stretch. So thank you for sticking with me so long. I really appreciate it. We're almost done. This is the last operation that we're going to talk about. So multiplication is the act of being given groups of a number and asked to find the total, right? So as we saw here, I told you there's 3 groups and there's 15 inside each group. So we find that total by doing multiplication. Well, division is backwards. You're given a total. So I say here in division, you are given a total and you're asked to put that total into groups of a certain number or a certain number of groups, right? So I think I have a problem written over here. No, I don't. So let's use that same problem like I was saying earlier. I give you a problem that says you have 45 Skittles. There's 3 bags. Can you figure out about how many Skittles are going to be inside each? You would read that, or the students would read that, and they would kind of dig into it and say, okay, I have 45 Skittles. That's my total. It's the total number of Skittles that we have. 45 Skittles. And it says that each bag has 15 Skittles in it. So that must be the size of my group. Or no, wait, I messed it up. I said there was, sorry. I said there was 3 bags. There's 3 bags of Skittles. And there's a total of 45. So they would say, okay, well, I have my groups. I know my total. I just don't know my group size. And so they would say, okay, well, because they know that multiplication, they're taught multiplication first, they would say, I know that this would be 3 times something would give me 45. So the way that I would solve that would be to do backwards multiplication. 45 divided into 3 groups would give me what? And so what they would do is they would take, we obviously don't use numbers this big. So let me see if I can, let's pretend it's not 45, just for the sake of me drawing this out here, because I am going to draw it out to show you what we show the kids. Let's say it's 15. Let's say the total is, let's say 12, because we already did 15 and I don't want to make it even more confusing. So we have a total of 12. Excuse me. So I have a total of 12 Skittles. There's 3 bags. How many Skittles are inside each bag? they would actually solve this by, again, drawing a visual model. This is the way that we teach kids new concepts, is let's draw something. I have a total. Let's draw each Skittle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12 Skittles here, and I know that they're going to go into 3 bags. I just need to find out how much is going to be inside each bag. So let's draw our 3 bags. 1, 2, 3. And let's this is painstaking and it takes a while, but let's go through it and let's just put it inside each bag. This is what division is. We're dividing a total into groups. It's the opposite of multiplication. We're dividing a total into groups. So I put my 1 here, put it in my bag. Cross out this one, put it in this bag. Cross out this one, put it in this bag. And we keep this process going. Obviously, this is not the most efficient way, but it teaches them the concept of what division actually is. We make them do this. And if we were in face-to-face class, if we were in person, I would give them real Skittles and I would have them take those Skittles and physically put them inside bags, right? So I would have them actually do this to understand the concept. Right now I'm showing you via virtually and also by drawing. So this is kind of the best way that I can show you how I would actually do it. But they could solve it this way too. If they didn't have anything to put in bags, they could draw a picture like this and they could say, okay, I've got 3 groups here. I took my total of 12 and I divided that into those 3 groups equally. So now my group size is going to be 4 because there's 4 inside each group. And we can do the same exact thing with a missing group size. Oh, I'm sorry, a missing group. Almost done here. So I have groups, group size, total. My total is, let's say, 12 Skittles again. And let's say I don't know how many bags there are, but I want to take my 12 Skittles and I want to put them into, let's say I want to put them into equal groups of 4. I have my 12 Skittles. I want to put them into equal groups of 4. How many equal groups can I put those in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have my 12 here. I'm going to make them and put them into groups of 4. Each group is going to have 4 in it. So let's circle this group. Boom, there's a group of 4. Boom, there's a group of 4. And last but not least, there's a group of 4. So we would know how many groups did I make? I made, show that mathematically by doing 12 divided into a group of 4. My size of group is going to be 4. How many groups do I make? 3. So I can model that where I'm just showing you there. Division could be that you don't know the size of the group, or it could be that you don't know how many groups there are. But the key thing about division is that you start with a total and you're dividing it into groups or sizes of groups. And then the very last thing I had was talking about fluency, because this is what parents really don't, the parents tend to think that we don't do this. Fluency is those multiplication tables that you had to do when you were in school where the teacher freaked you out and said, you have 1 minute to do all of these 2s and go, and you do all of them. We still do that, or we should still do that. If teachers aren't doing that, I don't think they're doing a very good job. You should still be doing that, because I don't want you to be in 8th grade drawing a picture of 2 groups of 3 to do 2 times 3. By 8th grade or by middle school, hopefully by 4th grade, because you learned this in 3rd grade. But by the time you get to middle school or high school, you don't need to be drawing 3 groups of 2 and drawing a tape diagram to show that. Hopefully, you've understood the fact that 3 times 2 is 6 and it's just ingrained in your brain. But in order to teach that concept, I like to show those pictures and all that. But yeah, it's still important and should still be utilized in class, fluency. The difference between fluency then and now is fluency isn't the only thing being taught to students. They should understand the why behind multiplication and division facts. But they should still practice fluency, and we still do. So people think that we don't do anything the same way. We really do. We still do fluency. We still practice it. It's just we spend a lot more time up front of explaining why 2 times 3 is 6 instead of saying 2 times 3 is 6, 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 right? You can see how having a deep understanding of these 4 operations in elementary school, you can see how it could help students easier grasp tough concepts, like here's some different things that we do in middle school that if they don't know how to do the 4 operations, it's going to be really tough. So using adding subtracting, multiplying, and dividing with fractions or decimals or negative numbers or really, really large numbers or exponents, or algebra where we give you a, 12 equals 35, right? So if you have a deep understanding of the things that we do in elementary school, it can help you with these things right here. And that's why we spend so much time, and that's why we give so many examples of the same thing and use so many different pictures and ways to solve similar problems. We want students to be able to understand tougher concepts down the road. The idea is that if we can understand the basic level stuff really, really deeply, if that's a word, in a really deep way, school, once they get to those higher level thinking skills, it might help them out later down the road, and it should. Once they understand it, then they can memorize it. So here's an example I'll leave you with here. My best example is I work part-time at a brewery, and I could probably, and we're adults here, so it's okay. It's okay to talk about this, but I could probably teach you the steps to brew a beer, right? I can teach you the steps, but that doesn't mean that you've learned the ins and the outs of the art of brewing. If there was a problem with the fermentation, you would have no idea what went wrong or even how to fix the problem. You would just know, well, this is the steps that they told me. I don't know what went wrong. Okay, well, what if I told you to brew a different style of beer? I have no idea, right? So you've learned the process, you've learned the steps, but you don't know it deeply. You don't understand it in a deep way, and you're not able to think on your own. You're having to rely on the steps that you've memorized. You did not learn that process. You just memorized steps. Okay, this is why we don't want to teach the memorization of steps. We want kids to learn everything about the process, not just memorizing the steps. And on that note, I am done teaching you.